Physical Science 20 Introduction and Review, Addition and Subtraction with Significant Figures. This lesson goes along with the IR4 assignment. Mr. Sklar drove to Regina one day and he wondered how much his car weighed. He knows that he weighs 86.4 kilograms, and when he rode across the weigh scale, it counted by tens and gave the weight of him in his automobile as 1,560 kilograms. How much does Mr. Sklar's Super Jetta weigh? Well, that's easy because when I'm sitting in my car, it weighs 1,560 kilograms. I know I weigh 86.4 kilograms, so if I subtract my weight from the weight of the car and myself, that tells me my car weighs exactly 1,473.6 kilograms. Or is that exact? Do I have confidence in all these numbers? Well, if I don't know what number was here, then that means when 4 was subtracted from it, I'm pretty sure that probably wouldn't be a 6. And since it counted by tens, I'm not exactly sure what this number actually is because it wasn't measured, right? The scale counted by tens. So 6 was subtracted by some number, we don't know what it was, so it probably wouldn't have been a 3. So the only numbers I have confidence in are the 1, the 4, and the 7. So I could say with confidence my car weighs 1,470 kilograms, but I couldn't be any more accurate than that. Mr. Sklar, his entire life, has been wondering how much a TI calculator, his favorite calculator of all time, he wants to know how much it weighs, cover and all. He is going to get 2 scales and we will solve this mystery. 2 scales because it is just too heavy or maybe just too important for just one scale. Now, had you been in class, we would have had 2 scales set up, and we would find that when we put the body of the calculator on the first scale, it read 127.24 grams. And when we put the cover on the other scale, it came out as 24.4 grams. 2 different scales, one measured to 2 decimal places, the other scale measured to 1 decimal place. When we added them up, we got 151.64 grams. Whew, mystery solved. Now, problem is, do I have confidence in all these numbers? Well, since the 1 scale only measured to 1 decimal place, that means I don't know what number would have gone here. So the 4 was being added to something. We're not exactly sure what it was. So that means I'm pretty certain this probably wouldn't be a 4 down here. So with confidence, I could say that the calculator weighs 151.6 grams. I can't show any more confidence than that because the 1 scale only measured to 1 decimal place. So a quick recap. We had 1,560 kilograms, subtract 86.4 kilograms, and we said in the end, we would wind up with significant figure-wise 1,470 kilograms. So that's 3 sig figs, subtract 3 sig figs, gave me 3 sig figs. That seems all right in our world so far. We've got 127.24 grams, and we added 24.4 grams to that, and we said with confidence we could say that the answer was 151.6 grams. So we had 5 significant figures, and we added a number that had 3 significant figures, and we wound up with an answer with 4 significant figures. Now, why is that important? Because this is different than multiplying and dividing. There are completely different rules in play. So let's learn what these rules are. Now would be a good time to take out some loose leaf and write down the title, Addition, Subtraction of Significant Figures. The rule is found on page 6 of the handout, so there's no need to write it down. But on page 6, we see the following rule. The answer will have significant figures to the same place. That's the tenths, ones, tens, as the number with the least accuracy in its measurement. When adding or subtracting, it is often a good idea to place numbers into columns and draw rounding lines. Example 1. We stack our numbers, just like we did in grade 2. Decimals lined up, ones over ones, tens over tens, tenths over tenths, hundredths over hundredths. And then we punch it into our calculator and make sure that it lines up with those numbers as well. Now the top number has 4 significant figures and it runs out after the 8. The bottom number has 6 significant figures and it runs out after the 4. Now I'm going to bring in my magic line of rounding and I move it from left to right until one of the numbers being added or subtracted has run out of significant figures. So as I go left to right, it is the top number that runs out of significant figures first, right after the 8. So that means in my answer, I'm going to keep 928.28 and I'm going to round off the 4. So my answer is then 928.28 meters. Now note, 12.08 had 4 significant figures, 916.204 had 6 significant figures, so that's 4 significant figures being added to 6 significant figures, and my answer in the end had 5 significant figures, because it doesn't matter how many significant figures are in the numbers being added or subtracted. All that matters is that we keep what's in front of that round off line, and we get rid of everything that's behind the round off line. Again, we line everything up in nice, neat columns. We punch it into our calculator and make sure that's also lined up in a nice, neat column. Tens over tens, hundreds over hundreds, thousands over thousands. Top number is 2 significant figures. It runs out after the 6. The bottom number has 3 significant figures running out after the 3. So when we bring our magic line of rounding into the equation and we move it from left to right, it is the bottom number this time that runs out of significant figures first after the 3. So we keep 195, we're going to round off 600. So 195,600 then rounds to 196,000 seconds. Example 3, again, we line it up in columns. 6,100 kilograms, subtract 2,130 kilograms, and our calculator says 3,970 kilograms. The top number runs out of significant figures after the 1. The second number, 2,130, runs out after the 3. So as I move my round off line from left to right, it is the top number that runs out of significant figures first, right after the 1. So that means I'm keeping 39, I'm getting rid of 70. So the 3,970, the 39 is going to bump up to 40. And that gives us 4,000 kilograms. Problem is, the first 2 numbers are significant, the remaining 2 zeros are not significant. This is a number that will have to go into scientific notation because we have to differentiate between the zeros that are significant and the zeros that are not. So again, 4.0 times 10 to the 3 is 4,000, and this number has 2 significant figures. Example 4, 379.4 meters per second plus 730.6 meters per second. We line it up in nice, neat columns. We then punch it into our calculator, and our calculator says 1,110. Now the top number runs out of significant figures after the 4. The second number runs out of significant figures after the 6. So as we go from left to right with our magic round off line, it's going to stop right after the, well, they both ran out at the same spot. So it's stopping after the 4 and after the 6. So we're keeping everything that's in front. We're getting rid of everything that's behind. Problem being, though, our round off line says we're keeping everything to 1 decimal place, and our calculator did not give us anything to 1 decimal place. So since it worked out to be exactly 1,110, that would be 0.0 repeating on our calculator because it worked out to an exact number. So we're going to have to add in the 0.0 so that our calculation is good also to 1 decimal place. So our final answer is 1,110.0 meters per second. And the final example, again, we're going to stack them up in nice, neat columns. We run it through our calculator. We get 0.006 as an answer. The top number has 3 significant figures. It runs out after the 0. The second number has 4 significant figures running out after the 4. So as I go from left to right, It's the top number that runs out of significant figures first, after that second 0. So that means I'm keeping everything that's in front, and I'm getting rid of the 6. Now, since I have nothing in front, I have 0.00, but if I'm dropping a 6, that's going to round up to 0.01 in front of the round-off line, which has one significant figure. So when I write that into scientific notation, that would give me 1 times 10 to the negative 2. Again, I only have one significant figure in my answer after the rounding. And that's the end of the lesson. Please go on to work on the IR4 assignment.